proportional versus non-proportional situations. In this video, we will be looking at tables of data only. So I want you to write down the situation as well as the table of data. You've been hired by your neighbors to babysit their children on Friday night. You are paid $8 an hour. Complete the table relating your pay to the number of hours you worked. So I'd like you to, again, copy this down, and I want you to go ahead and fill in the pay. And then we're going to talk about whether or not your pay is proportional to the hours that you worked. Alright, so when you have this table of data completed, your table should match what I have here in my table. Now, the first thing that I want you to do is to think about, if you were to plot this on a graph, which values would represent your x values and which values would represent your y values. So in this particular situation, our hours worked is our independent variable, and that determines our pay, which would be our y values, or our dependent variable. Okay, so now let's take a look at the question here. Based on the table, is pay proportional to the hours worked? Well, one thing that I want to point out is what we know about proportional relationships. We know that if we graph proportional relationships, they will pass through the origin. They also show a direct variation, and they can also be expressed by the equation y equals kx. So in this situation, let's think about if it would actually pass through the origin if we graphed it. So if we worked 0 hours, what would our pay be? Our pay would also be 0. So now we have to show whether or not there's a direct variation, whether or not basically if our slope is going to be the same throughout the situation. And then let's think about how we might write an equation. So remember that our slope, or in this situation, well, our slope is the change in y over the change in x. And we talked about using the equation y2 minus y1 over x2 minus x1. So let's just choose 2 points. So let's say we graphed this first point 1, 8, and then the second point 16, 8. I'm sorry, 2, 16. So let's go ahead and determine what is our change between y2 and y1 here, 8, and then between x2 and x1 we have a change of 1. So in this situation, our slope, or our k, is 8 over 1, which is just 8. Let's pick another 2 points. Let's choose 3, 24, and 4, 32. What is our distance here between 32 and 24 is 8, and then between 4 and 3 is 1. So it looks like our slope, or it looks like we do have a consistent proportional relationship between hours and pay. Our slope, or our k, is 8. So if we were to write out this as an equation, we would say that y equals kx, or y equals 8 times x. And if you think about substituting in 8 times the number of hours, that should give you your pay. So is this a proportional situation? Yes. And we see that it satisfies all of these criteria. So now I want you to take a look at the next situation. The table below shows the amount of snowfall in 5 countries in inches to the hours of recent winter storm. And then the second one is the table shows the relationship between cost of renting a movie to the number of days on rent. So what I would like you to do is determine whether or not you have a proportional relationship. Time and snowfall, and then number of days and cost of renting a movie. Tell me yes or no, is there a proportional relationship, and why? Alright, so in this first situation, what I did is I determined my slope for the first 2 points. So my change in y is going to be 2 over my change in x, which is 4. And I know that that simplifies to 1/2. Now, so if I plotted these 2 points, my slope would be 1/2. But if I continue and I plot the next 2 points, or the third and the fourth point, I would determine that my slope is 11 over 5.5, which is not equal to 1/2. So we do not have a direct variation. There is not a proportional relationship between snowfall and time. So again, this situation is not proportional. There is no direct variation. Now go ahead and do the second situation. Alright, so in this second situation, what I did was I took my first 2 points and I found the difference between the y's, y2 minus y1, and then I did x2 minus x1. So you get 1 over 3. So my slope is 1/3. In between my second, or my third and my fourth point, my y2 minus y1 is -7, and then my x2 minus x1 is -21. And we know that negative divided by a negative is a positive, and we can simplify 7/21 to 1/3. So, do we have the same slope? Yes, we do. There is a direct variation. So in this particular situation, we do have a proportional relationship because we can say that y equals 1/3 of our x's. And if you plug your values in, you should get a true statement. So in this situation, yes, we do have a proportional relationship. So pause and rewind as much as you need to understand how to use tables to distinguish proportional versus non-proportional relationships. And I would like you to write a brief summary describing how to distinguish proportional versus non-proportional relationships just based on a table of data.